Marketers from a well-known toothpaste company are interested in brand loyalty for two different age groups, those who are under 30 and those who are 30 or older. The participants were those who indicated they always buy the same brand of toothpaste. They were asked, if another brand offered you a similar type of toothpaste for a 10% discount, would you switch brands? Out of 300 respondents under 30, 162 said yes, they would switch. Out of 240 respondents who are 30 or older, 115 said yes. We want to conduct a significance test at the 1% level to determine if there's a difference in the population proportions of people who would switch brands for these two different age groups. We'll start by finding our sample proportions for the two different groups. For group 1, what we have is 162 out of 300 people. So P1 hat, 162 over 300 is 0.54. For group 2, we have 115 out of 240 people, which gives us 0.4792. When doing a hypothesis test for a difference in proportions, we also need our pooled p-hat, which clumps together information for both groups of people. So if we take for both groups and look at that we have 162 saying yes and 115 saying yes, we add those in the numerator, and then the denominator is the total number of people, so 300 plus 240, for a common proportion of 0.513. So what we want to find out here is if there's a difference in the proportions. So when doing our test, we'll test if the two proportions are the same. We can write that null as P1 minus P2 equal to 0, or equivalently as P1 equal to P2. And since we just want to know if there's a difference, we will do our two-tailed test, and we'll do a not equal to. So what our test statistic for this test looks like is a difference in sample proportions on the top. So we will take our 0.54 minus 0.4792, and in the numerator we do the square root of our p-hat times 1 minus p-hat over the sample size for each of the groups, and we add those together. And this is going to give us 1.40. We next need to find our p-value. Because we have a not equal to, we're doing a two-tailed test, and so we want the area in both tails beyond 1.4 and negative 1.4. So the picture would look like this, where we want the shaded area in both of these tails, and these are both the same since the normal is symmetric about 0, so we can really just look up one of those areas and then multiply by 2. So if we wrote it out, we would do the probability that z is less than negative 1.40 plus the probability that z is greater than positive 1.40. These are equivalent though, so this is 2 times the probability z is less than negative 1.40. And I just chose that one because that one we can get directly from the table. So if you go look for negative 1.4 in the margin of your normal table, what you'll find for the probability is 0.0808. We're multiplying that by 2 to get the probability in both tails. So we get a p-value of 0.1616. We're doing this test at a 1% level, and we see this is greater than 0.01. When our p-value is larger than our significance level, we are not going to reject our null. So what we get for a conclusion here is that there is not significant evidence of a difference in the population proportions who would switch toothpaste for the two different groups. So we're finding there is no difference in the two proportions if we were to write that out. If you go back a couple podcasts earlier and look at finding a confidence interval for the same problem, what you'll see there is that what we found was 0 was contained in the interval and that there was no difference in proportions. Those two things should match up. If you're doing a confidence interval at a 99% level and a two-tailed test at a 1% level, what you should find is that your conclusions are identical and that we're not finding a difference in the proportions here for the two different age groups.